So I did 1D, 1C, and 2D. I basically tackled both number one questions similarly. I actually did them without using the rules, which is kind of an odd way to do it, but that's just how I taught myself to do it over this time alone. So let's go into number 1D. First I started with, this is the original question, and I first started by getting the domain, which would help me find the which one is the real root. And then I was trying to get the base the same, so in this case make it 3 because it was originally 9, so 3 squared. And then what I did after that was get rid of the squared by bringing it out front and making it a coefficient of the log. So once I got the bases the same, I could add up the coefficients and basically simplify. So then once I simplified down to this, I solved by solving for x. And I ended up getting x equals 9, which is greater than 0, so therefore it's a real root. And as you can see, I did a similar thing with 1c. This is the original question. This time, since I had 8 and 4 and 2, I decided to make the bases 2 in exponential form. So I got 2 to the 4, 2 squared, and 2 over here. So I did the same thing I did in D by bringing the exponents out in front here. And then I can add up the coefficients, basically simplifying. I ended up getting 2 to the 1 over 28, which is greater than 0, therefore it's a real root. And down here we got 2D, and I made AI, or AF, the final amount, AI initial amount, G is the growth, which is times 2, T is the time, which is total days, which we're looking for, and X is the time between the growth, which is 4 days every 4 days it doubles. So what I did here is I made up a formula. I plugged in the values, and from there it was pretty simple, just solving for T. And once I solved for T, I got 10.4 days. The original bacteria, which started at 1200, grows to 100,000.